For the reactions of alkanes, first of all, we want to talk about something related to alkanes first. Like in fact, for alkanes, it is a kind of hydrocarbons. And then it's for hydrocarbons, we say that alkanes is the saturated one. So the saturated alkanes, where can we get it from? It should be from the petroleum. Petroleum mainly consists of hydrocarbons, that is, containing hydrogen and carbon atoms, while it can be distinguished into saturated or unsaturated. For saturated one, it should be containing hydrocarbons containing only single bonds, while unsaturated one, it's containing one or more carbon-carbon double bonds or multiple bonds, carbon double bonds or carbon-carbon triple bonds. So these are the examples for the saturated and the unsaturated hydrocarbons. So saturated hydrocarbons, we name it as alkane, while unsaturated one, we name it as alkenes. And some of the facts that we need to talk about with is about the strict chain alkanes. In fact, most of the time, the strict chain is somehow misleading. So let's take a look for the ball and stick model. If you can see clearly, in fact, the ball and stick model is somehow zigzag in shape. That is, they are not really a straight line, but we always say that this is still a straight chain. Now, due to the bonding angle, they have to twist to 109.5 degrees. So they will never show with the straight chain. So although we say that straight chain, it doesn't mean that it's a planar or it's just follow a straight line shape. So let's go into the details for the alkanes properties. Now, some of the alkane properties we have discussed before in chapter 21, but we want to pinpoint one, that is the boiling points. Like you can take a look for this one. The boiling points, we find that the higher members of the alkanes, it should be having a higher boiling points as well. So starting with 1 carbons to 10 carbons, their boiling points in general, it is increasing. This is because of the greater the molecular size, the greater the intermolecular it will have. So that means the hydrocarbons containing 10 carbon atoms inside, it will have a greater molecular size. And then the greater the molecular size it has, it will have a greater intermolecular force. As a result of that, we find that the boiling points will be higher because of the greater intermolecular force. So let's go to some chemical properties of alkenes. Like in fact, for alkenes, all of them having the similar chemical properties because they all have the similar structure, that is CH and then CC single bonds. All of the alkanes are unreactive. So because CC and CH bond, they are very, very stable and strong. So that's why the alkanes do not react with the acids, alkalines, oxidizing agents, or reducing agents. So in fact, we say that alkanes somehow inert. Because CC single bond and then the CH bond are strong, they seldom react. They just only present for some of the reactions, mainly classified to 3. 1, first of all, we have to state that alkanes, as this is very, very unreactive. As a result, it can be even used to cover those reactive metals. The sodium is a very reactive metal, and it cannot react with the alkanes. That's true. In fact, the alkanes somehow very, very unreactive. Well, we just only have a few reactions for the alkanes. The first one is combustion, that is burning. Like in fact, burning can occur almost all the any stuff. So a lot of stuff can even burn. For example, we can burn the plastic, although they are very chemically inert, or even the metals. Some of the metals, for example, iron can also can burn in the air. So if it is a very, very rigorous one, alkanes can react with it. As a result, combustion of alkanes, substitution reaction with halogens, and then the last one, cracking. So let's start with the combustion first. But the combustion alkanes burn in air to give out heat or light energy. So alkanes most of the time is used as fuels. These are the general formula or the general equations for the complete combustion. So if we have methane and then burns with carbon dioxide, then it will give out carbon dioxide and then water. Now, here, if you're using the general equations, then you just need to direct substitute the x, y, then you will get the numbers here. However, on the other hand, if it is a complete combustion, it must give out CO2 and then water. So you may not, it is not necessary for you to remember the general equation, but you just need to remember about the products that formed and then balance it by yourself. How about C2H6? If we use the general formula, we can also give this one 4CO2 and then 6H2O. Anyway, this is one of the methods that we can use it. So under the general condition, the ordinary one, combustion of alkanes is often incomplete. Carbon dioxide, water, carbon monoxide, and soot unburned carbon particles will be produced. Like under certain conditions, should be saying under certain conditions. So the combustion of alkanes is often incomplete. Now, just because when we are talking about burning, we need to have sufficient of oxygen. If there is not sufficient of oxygen, then carbon dioxide, water, or carbon monoxide, soot, that is unburned carbon particles, will be given out. So let's take a look for this one in our textbook. Methane is a major component of the gaseous fuel used in Bunsen burner. Explain why, with the aid of chemical equation, why a non-luminous flame is obtained when the air hole of a Bunsen burner is fully opened. Just because, like, if we fully open the Bunsen burner, the air hole, there should be enough oxygen provided and then make it burn. Complete combustion of methane will be given. So it will become CO2 and H2O. As complete combustion given, so a non-luminous flame will be obtained. Just because it will not given out at light energy, it will given out most likely the heat energy instead of the light energy. So here is one of the figure that we have. If the air hole is fully closed, it should be given out a non-luminous one with some carbon soot inside. Just because when it is air hole closed, that means not sufficient oxygen. They can get oxygen here, but at that moment of time, it is not enough to burn in a very, very fast way. As a result, we just burn incompletely to give the luminous flame. However, if the air hole is fully opened, then there should be sufficient oxygen. All the alkanes has been burnt and give out all the energy. The energy is high enough to give as heat energy, but not the light energy. So when it is fully opened, it will be non-luminous one. So next one, compare with methane, butane burns with a more sooty flame. Explain briefly. Now, for butane, it contains 4 carbons in the carbon chain, while methane, it contains 1 carbon in the carbon chain. As a result, butane has a greater number of carbon atoms in its molecules than methane. Hence, it burns less completely with a more sooty flame than methane. That is, it is more difficult to burn, in fact, just because when we found that the alkanes present here, butane have 4 carbon, needs more oxygen. So it is more difficult to burn completely compared with the methane. So another example for you to consider, you may pause it for a while and then you can see whether you can choose the correct answer here. The cell below is used to show hexane contains carbon and hydrogen. What are X and Y? Now, to show That is here. We want to show the hexane containing carbon and hydrogen. So we burn it. So first of all, we need to know burning carbon will give out carbon dioxide, while the lime water that's present can be used to test the carbon dioxide. While for hydrogen, after burning, it will become water. So the water can be tested with the anhydrous copper 2 chloride or anhydrous copper 2 sulfate. So copper 2 chloride, when it's getting some moisture, water, it will turn pink. It will turn to pink color. So anhydrous one, blue, and then it's changed to pink color. Well, if you add to the anhydrous copper 2 sulfate, then copper 2 sulfate will turn from white to blue. As a result, as the one that's fulfilling lime water to test the carbon dioxide, and then the next one testing the water, then it should be answer C. So this is the short summary here. The alkanes, in fact, we have a general formula. The general formula that we have should be CnH2n plus 2. This should be CnH2n plus 2. While when we burn, so don't forget, if it is completely combust, then it will be carbon dioxide and water vapor given. So if you don't remember about the general rule, then you just need to balance one carbon on the left-hand side, then you should get one carbon dioxide. So 4 hydrogen on the left-hand side, so you should get 2 H2O. As a result, how many oxygen shall I have? So it should be 1 O2 plus another O2. 2 oxygen means 1 O2. As a result, you need 2 O2 here. While ethane, when it is burned, it will be given out CO2. Like for this part, I will use the method fixing this one with 1 C2H6 first, and then we will get 2 CO2 out. While when we continue, should be having 3 H2O, because we have 6 hydrogen on the left-hand side, you should get 6 hydrogen on the right-hand side as well. So adding them up, how many oxygen that we have? It should be 1.5 O2 now, because 3 oxygen means there should be 1.5 oxygen O2. So adding together, it should be 3.5 O2. But you have to remember that there should be no 0.5 in the chemical equation. So we need to multiply the whole equation by 2. Hence, we need to change it. Here, it will be 2C2H6, while we have 7O2, 4CO2, and then 6 H2O. So 2746 will be its numbers. If it is a complete combustion of alkanes, then blue and clean with a less sooty flame is observed. Like that means reversed. If it is incomplete, a yellow and then sooty flame is observed. That is the combustion.